Hi guys, welcome back to this channel. My name is Ananda Dwi Putra Tafira. So today I just wanna explain about linear programming. Okay, so the first question is a manufacturer produced two models of racing bike B and C, each of which must be processed through two machine shops. So we example that bike B as X and bike C as Y. Machine Shop 1 is available for 120 hours per month and Machine Shop 2 for 180 hours per month. The manufacturer of each bike of type B takes 6 hours in Shop 1 and 3 hours in Shop 2. So the first equation is Machine Shop 1 is 6x because the question that mentioned type B takes 6 hours in Shop 1. And then for C are 4. So 6x plus 4y is less than or greater to 120. And then the equation 2 is from machine shop 2. 3x is from this 3 hours in shop 2. And then for C are 10 hours. So the equation 2 is 3x plus 10y is less than or equal to 180. And then if the profit is 180 and 220 per bike of type B and C, respectively, how should the manufacturer arrange production to maximize total profit? From the question that we get, the equation of profit is 180x plus 220y. Next, from the equation, we find the x and y. The first equation is 6x plus 4y is equal to 120. If x is equal to 0, so y is equal to 120, we divide it by 4 and the result is 30. And then if y is equal to 0, so x is equal to 120, we divide it by 6 and the result is 20. So the point of the first equation is 20, 30. And then the second equation is 3x plus 10y is equal to 180. If x is equal to 0, so y is equal to 180, we divide it by 10 and the result is 18. And if y is equal to 0, so x is equal to 180, we divide it by 3 and the result is 60. So the point is 60, 18. And then we find the intersection point. To find intersection point, we must eliminate the first equation and the second equation. The first equation we multiplied by 1 and the second equation we multiplied by 2. 6x plus 4y is equal to 120. 6x plus 20y is equal to 360. 6x plus 6x minus 6x is 0 and then 4y we minus with 20y, the result is minus 16y. 120 minus 360, the result is minus 240. So y is equal to minus 2040, we divide it by minus 16 and then the result is 15. And then next we find the value of x. We add the y value to the first equation and then we get x is equal to 10. So the point is 10, 15. So this is the graph. We shade the region above the line because we not interested in this region. We interest in this region. This is the visible region. Visible region have three corners. First is 0, 18 and then 20, 0 and the last is 10, 15. And then we put it to the profit equation 180x plus 220y. If the corner is 0, 18, so the profit is 3,960, and if the corner is 20,0, so the profit is 3,600. And if the corner is 10,15, so the profit is 5,100. This is the maximum profit. So to maximize profit, we should produce 10 bike B and 15 bike C. Next question. An Italian restaurant offers a choice of pasta or pizza meals. It costs $3 to make a pasta dish which it sells for $13. The corresponding figures for pizzas are $2 and $10 respectively. The maximum number of meals that can be cooked in a week is 1,200, and the restaurant has a weekly cost budget of $3,000. How many pasta and pizza dishes should be cooked each week to maximize profit? From the question that we can get, for example, pasta as X and pizza as Y. And then cost of pasta is $3, cost of pizza is $2. So the equation is 3x plus 2y is less than or equal to 3,000 because weekly cost budget is 3,000. And then number of meals that can be cooked in a week is 1,200. So x plus y is less than or equal to 1,200. And then to get profit of pasta, we minus the sales with cost production. So profit of pasta is equal to 10, and profit of pizza is 10 minus 2 and equal to x. So profit is 10x plus 8y. From the equation, we find the value of x and y. If x is equal to 0, so y is equal to 3,000, we divide it by 2, and then the result is 1,500. And if y is equal to 0, so x is equal to 3,000, we divide it by 3, and then the result is 1,000. So the point is 1,500, 1,000. And then the second equation is x plus y is equal to 1,200. If x is equal to 0, so y is equal to 1,200. And if y is equal to 0, so x is equal to 1,200. So the point of second equation is 1,200, 1,200. And then next, we find the intersection points. As usually, we eliminate the first equation and second equation. First equation we multiplied by 1, and second equation we multiplied by 2. 3x plus 2y is equal to 3,000. 2x plus 2y is equal to 2,400. So 2y minus 2y is 0. 3x minus 2x is x. And then 3,000 we minus with 2,400. So x is equal to 600. And then x plus y is equal to 1,200. This, the value of x is 600. And then plus y is equal to 1,200. Y is equal to 1,200 minus 600, and then the result is 600. So the point of intersection is 600, 600. So this is the graph. We shade the region above the line because we're not interested in this region. We interest in this region. below the line. This is the visible region. The visible region has three corners. The first is 0,1200, second is 1000, 0, and the last is 600, 600. And then we put the corners into the equation of profit. If the corner is 0,1200, the profit is equal to 9600. And if the corner is 1000, 0, and then the profit is equal to 1000. And if the corner is 600, 600, the profit is equal to 10,800. This is the maximum profit. So to maximize profit, we must produce 600 of pasta and 600 of pizza. And the last, a small manufacturer produces two kinds of good A and B for which demand exceeds capacity. The production costs for each item of A and B are $6 and $3 respectively, and the corresponding selling price are $7 and $4. In addition, transport costs are 20 cents and 30 cents for each good of type A and B respectively. The conditions of a bank loan limit the manufacturer to maximum weekly production cost of 2,700 and maximum weekly transport cost of 120. How should the manufacturer arrange production to maximize profit? So from the question, we get example that goods A is equal to X and goods B is equal to Y. And then cost production of A is equal to $6. Cost production of B is equal to $3. And then selling price of A is equal to $7 and selling price of B is equal to $4. And then transport costs are 20 cents. We change it into dollars. So transport cost of A is equal to $0.2 and transport cost of B is equal to $0.3. And then we get the equation 6x plus 2y less than or equal to 2,700. This is maximum weekly production cost. And then second equation we got 0.2x plus 0.3y less than or equal to 120. This is the maximum weekly transport cost of 120. And then next, we find the value of x and y to draw the graph. First equation is 6x plus 3y is equal to 2,700. If x is equal to 0, so y is equal to 2,700. We divide it by 3 and then the result is 900. And then if y is equal to 0, so x is equal to 2,700. We divide it by 6 and then the result is 450. So the point of the first equation is 450, 900. And then second equation 0.2x plus 0.3y is equal to 120. If x is equal to 0, so y is equal to 120. We divide it by 0.3 and then the result is 400. And then if y is equal to 0, so x is equal to 120. We divide it by 0.2, so the result is 600. And then we get 600.400. Next, we find the intersection points. To find intersection points, we eliminate the first equation and the second equation. And then the first equation we multiply it by 1 and the second equation we multiply it by 10. 6x plus 3y is equal to 2,700. 2x plus 3y is equal to 1200, and then 3y we minus with 3y, the result is 0, and then 6x minus 2x is equal to 4x, and then 2700 we minus with 1200, the result is 1500, and then x is equal to 1500, we divide it with 4, and the result is 375. And then to find the value of y, we put the value of x to the first equation, and then we find the value of y is equal to 150. So the intersection point is 375, 150. So this is the graph. We set the region above the line because we're not interested in this region. We interest with this region. This is the visible region. And then we got three corners. First is 0, 400, and then second is 450, 0, and the last is 375, 150. To find gross profit, we minus the selling price with cost production. So goods A is equal to 1 and goods B is equal to 1. If the corner is equal to 0.400, so the gross profit is equal to 400. And if the corner is 450, 0, so the gross profit is equal to 450. And the last, if the corner is 375, 150, so the gross profit is equal to 525. And next, we find the transport cost. If the corner is equal to 0,400, so the transport cost is equal to 120. And if the corner is equal to 450, 0, so the transport cost is equal to 450. And if the corner is 375, 150, so the transport cost is equal to 120. And the last, we find the net profit. We can find the net profit by minus the gross profit with transport cost. And then if the corner is 0,400, so the net profit is equal to 400 minus 120. And then if the corner is 450, 0, so the net profit is 450 minus 450, and the net profit is 0. And then if the corner is 375, 150, so the net profit is 525 minus 120. So the result is 405. This is the maximum profit. So to maximize the profit, we need 375 of goods A and 150 of goods B.